Hi, thank you guys so much for coming today, and thank you, Jenna, for the insightful conversation. And we're now going to move into the 3D printer manufacturers panel, Innovate and Elevate. So today we have three 3D printer construction printer company here with us today to discuss the current technological landscape of the industry and what does the future integration look like. My name is Alice and I'm an industrial design student here at Georgia Tech. It is my honor today to be moderating for this panel and introduce our panelists and their printers. To start off with, we have Bruce, who is the CEO of X-Hab 3D. X-Hab 3D has developed a 3D CP system that's mobile, self-sufficient, and uses local concrete. And then we have Anna, who is on camera with us right now. She's the CEO of Apis Core. Apis Core's Frank, and as you can see on the screen, and Gary has a zero cost for deployment and transportation. Only needs one person to operate the machine and can print any size houses without additional cost to construction. And lastly, we have Giulio, who's the sales manager at WASP 3D. Within the line of WASP 3D printers, Crane WASP is a modular printer that's focused on building construction using sustainable materials. And Crane WASP has a setup time of just 2 hours with 3 people. And we would like to give a warm welcome to all our panelists. Awesome. So we'll start off by asking, I think many people are concerned about the aesthetic difference between 3D printed houses and traditional houses. But we saw in the beginning with some pictures that you all took different approaches to that aesthetic of the 3D printed houses. Bruce, can you tell us a little bit about how does your print head relates to that unique layering appearance?
Sure, I'd be happy to. So first of all, our approach is to make our 3D concrete printing system and print head as flexible as possible. The appearance of the concrete layers is really dictated by several different factors, including print head design, material properties, aesthetic preferences, and environmental considerations. So with respect to the print head, the shape, size, and movement of the print head, along with the extrusion rate, setting time, collectively dictate the width, thickness, speed, and precision of the concrete deposition and directly impact the appearance and the quality of the printed layers. Now, having said that, you can pretty much make the exterior of the concrete print look just about like whatever you like. You can have it beaded, and I'm sure some of you have seen that. You can have it rectangular. You can use a trowel at the end of the end of the print head to smooth it out. You can even spray it with shotcrete or some sort of an exterior layer to make it look just about like anything you want. So from a housing standpoint, if you look at a 3D concrete printed house from the street, a traditional craftsman style design, you're not going to see much difference. And in Europe, of course, people have been using concrete and stucco and things of that nature for 1,000 years. And so I think in part, the United States just needs to catch up with that because it's better quality product.
Of course, and I know Apis Core has chosen very specifically developing a style of print head. Can you tell us a little bit about the decision behind that?
Yeah, absolutely. First of all, thank you for having me today. Real pleasure to be together with this incredible people who pushing forward the innovations. But about us, we are more driven by unit economics. And our goal is how to help home builders to build more homes. That's just as simple as this. And we just look at the more massive market, I would say. It's single family housing here in the United States. And you have to be very cost effective with new technologies if you really want to make an impact at scale, right? So like the problem is that people need homes. And yes, if they come with the better architecture, that's nice, but they also have to come with the better price. And it also have to be more of them. And we believe that, and I think it's just really like a common sense. If you want to revolutionize such a outdated and conservative industry like construction, you really have to figure out how to be integrated into the existing processes and supply chain, because changing the construction just overnight, it's not possible. So this is why we were thinking about unit economics. How much does it cost right now to build wall structures, and how we can meet and even like be more affordable with new technologies. That defined the end product, the wall structure. This is why we have pretty small layers compared to any other company in the space, because this is like how much material you extrude, and you still need to be to build walls that are safe and sound. So everything like design of our robots actually came first from the what the end product should be from the unit economic perspective. So once we figure out, okay, this is how the wall, 3D printed wall should look like to be at least the same prices as today in the construction. This is how the mixer and pump unit should look like. This is how the hoses, the length of the hoses, that really defined the architecture of the robots and especially the mixer and pump machinery. So as of today, we do know how to even beat traditional construction, not only with the small and mid-sized companies, help small and mid-sized companies to do that, but also work with the national home builders who, because they operate in different scale and economics, they have different pricing, right? But even right now, we do know how to compete with their prices as well. So we can provide the solution that will help all of the home builders in the industry to build more homes at the same price or even lower. So yeah, that was basically the idea behind the extruder that we have. It has to layers have to be really small, and then the entire architecture, print head, printer, mixer and pump machine, and also the material delivery system was born based on that fundamentals, how to be compatible and how to compete with the existing prices and unit economics.
Amazing. And Giulio, I know unlike Bruce and Anna, your company takes a different approach with only with really a strong focus on natural materials. So can you tell us a bit, why did you guys make that choice, and how do you deal with the aesthetic that comes with a natural material?
Yeah, sure. First, thank you very much, and hello from our headquarters. I'm calling from Italy, and I'm very excited to be here and having this opportunity with you. For us, the sustainability has always been the first goal, and our name itself, the WASP, comes from nature. It comes from the animal that really grabs the mud and turns it into the house. So for us, the maximum aspiration we can have as technological designers is getting there. So as close as possible we can get to the nature. For this reason, we developed since the very early days a whole pumping system and machine to work with these materials that have been long forgotten in construction, but actually are part of our civilization since 1,000 years. So we believe that technology could create like new paths, new ways for working with this material, overcoming the limitation that forced people to break their backbones basically for constructing with soil. Soil and clay has actually scientifically impressive thermal insulation properties, and it can provide a great way of using local material. In 2018, 6 years ago, we printed Gaia, our first proof of concept to demonstrate this was possible. And I think it already contained a lot of the contents that we are trying to push today with all the collaboration and the expansion of the technology. I agree a lot with what Bruce and Anna were saying about the idea of finding new ways, new approaches. And there is really a revolution, I think, happening in construction. Sometimes for us in Europe, it's a lot about explaining people that we are not trying to mimic traditional construction. We are trying to go past it and really revolutionize some parts of how you design, how you think, even how you perceive your house. And I think this is especially important when we think about sustainable material. I like to think that one day we will be living in houses that will be getting back to the ground after we live there. And this, I think, it's the kind of vision that is guiding us, and it's been shaping the product. All our hardware, all our projects try to reflect this.
Yeah, thank you so much. And that's such a great segment into our next question. In history, we've seen construction industry taking advantage of local resources. Yet global supply chain has vastly changed that now. There's still some differences between regions, but we see much across. But how do you guys decide what type of material that your printer is going to be print? We'll start with Bruce.
So, well, thank you for that. That is an absolutely critical question. And I will say that the material it's really part of a systems level decision. And people don't realize that it's not just about the hardware or the software, but the material is absolutely critical to making this work. I was about to say that it's not rocket science, but it really kind of is. And in fact, one of our contracts is working with NASA to use microwave technology to process lunar regolith. But the use cases work right back to our planet. We are one of the reasons we are working very closely with Penn State University is because they have one of the best material science schools in the U.S., if not the world. And we also have our own material scientist on staff. It's an absolutely critical component to our business for the base materials to make sure that there are reliable performance materials that we know work and meet the requirements, not just of houses, but any kind of structure we're going to print. Absolutely, totally critical. It has to be pumpable. It has to have the structural capability. And there are all kinds of characteristics that are not obvious when you put this together. Second, from an accessibility standpoint, these machines are expensive. We're trying to change the way construction is done. And so this material really needs to be very accessible to whoever is using this machine. So our approach is to look at how do we make sure that the materials can be sourced at the local and produced at the local level so that there's never a bottleneck from supply chain issues and things of that nature. The third thing that Anna was emphasizing, and we totally agree with, is cost effectiveness. There are different ways to do this. You can have pre-blended super sacks of material that are delivered to the site, or volumetric mixers that bring all of the material there, and all you have to do is print with the right ratios of water, or to even further reduce the cost, you can batch on site. And then finally, where we ultimately want to go is to move away from Portland-based cement and look at alternatives like magnesium-based or alkali-activated, other kinds of things that are much better for the planet. And we're working with DARPA and other government agencies on projects to move that forward. So in summary, materials are absolutely critical to everything we do.
Absolutely. And then I will bring it back to Anna. And I understand as a part of your product line, there is also a mixer. Can you tell us about how did you choose the material and how did you decide your product line?
Oh yeah, absolutely. And I absolutely agree with Bruce with everything you said about the pumpability, accessibility, and actually about the rocket science. I just want to say that it's not rocket science, but at the same time, knowing how complex it is rocket science. So because you need to figure out the material that it has to be pumpable, has to be extruded within the speed of your printer, and it's a lot of changing characteristics, and like I all the time imagine this as the equalizer, and with the material, you just you mess up a little bit with some of the accelerators and it doesn't work. Everything is stuck in the hoses, for example. So this is why we are so also picky about the materials. We have our formulas for the 3D printed concrete. We tested it when we 3D printed the biggest building on earth in Dubai. It's a still Guinness World Record. So we used also locally sourced materials, and it was just our formula adjusted to that. Right now we use the cement mortar, and I would say that it's not a regular concrete. Regular concrete cannot be extruded. So sometimes people kind of confuse it, I can go in the ready mix concrete and just buy the concrete and extrude it. No, you don't. You can't do this. So the materials for the 3D printing, it can be designed in multiple ways, and every company has their proprietary formula. and each of them can work. So this is why I'm saying like it's not really rocket science because it's like there are multiple ways how you can create it, but at the same time, even to create one of them, it's a rocket science. So then you need to figure out how these materials can be produced locally, so every construction company can have access to it. And at the same time, you also need to think about the logistics, how you bring this material to the site, because just to 3D print walls for single family house, it can be about like a 40,000 pounds to, I don't know, 80,000 pounds, depending on what wall structure you print and what's your design of the walls. So imagine loading all of this enormous amount of material to the printer. You can do this manually. I mean, you can, but it's not really scalable. And it's all affect like ruin unit economics immediately. Then even if you bring it in a super sacks, we also did that before. It also like you need to load this super sacks to the printer and mixer. So it's all create additional costs. So in addition to material that we created, we also created the material delivery system. So right now we use standard bulk trucks that supply, like bring the material directly to the site. And this material already blended at the factory. So we don't do any mixing, actually like a blending on site, because this is where also a lot of problems can be created. So the idea is to create the material, dry powder in the form of dry powder at the factory, following the formula, following the quality control procedures, put it in the like a sealed bulk truck. It's basically like a big barrel on the wheels, and then it's not exposed to the humidity. Then nobody touched that. So it's basically like, you know, your material created as you need. And then it comes to the site and it just mixed with water automatically in the mixer and pump machinery. So this is how we completely reduce the human error related to the material. So yeah, as you see, it's like we did create the material in like several materials, but we also thought about how to make sure that this material is going to possess the same physical characteristics that it's supposed to when we created this in a lab. So that's really important. And also we foresee that we go into transition to the geopolymer materials or materials with the less cement, because that's going to be huge environmental impact in the industry. Even today, we use 12% less cement that's used in concrete masonry unit construction. So even today, we make the impact just in the material side. But at the same time, because we figure out this bulk truck delivery system, we can reduce up to 3 times of gas emissions. Because if you build with the concrete blocks, you need about 3 trucks to deliver the concrete blocks to the site. In our case scenario, just one bulk truck, and it comes with all of the material needed to build the same structure. So yeah, I would say that's very holistic approach that we take whenever we just create the materials or technology or wall design or like construction documents. You know, it's like it's really a pretty complex set of technologies, I would say. So you need to think about everything. Yeah.
Yeah, and Giulio, we'll bring it back to you, who started this question, really. You know, I understand WASP comes from a background really with clay printers, and now that you're printing houses. So how did you make that transition with the material, and how did you develop it?
Yeah, so for us, I think that the material is probably the main goal for us. So I believe, if I should say, that the most impactful difference in the world we can make it with the material, not with the printing itself. So if we can make more people to print really with the local material, with soil, that's the goal. If tomorrow this means transitioning to something that is not printing, I say that it will be worth, because this is how you make sustainability. At the same time, we are machine experts, we are industrial designers. It's a great challenge. We found in the years to be the most difficult thing. As everyone was saying before, that's probably the most complex thing, because there is so many things and so many complexities. Is at the same time super fascinating and super challenging to develop sustainable alternatives. I really agree with Bruce when he says that it's not like you have sustainable or not sustainable. It's a spectrum. So LCA, it's complex. It's even requiring a lot of studies, numbers. For example, you make it locally, you don't make it locally. Maybe something more chemical made with something local is better than something natural that is transported. So all these topics must be on the table. We are developing because of this, because we also want our technology to be available and suitable today. All the real application aside of the clay printing that we are promoting. So we are researching on lime printing. We use a lot, geopolymer, hempcrete. This is all options that we need on the table and that we test on our pumps on daily basis, because this is what makes the application. Just another thing, if you need something structural, you will need, in some cases, cement. You have no alternative if you want that strength. So it's also a matter of, is it sustainable to make something that will break? No, I don't think so. So we have to evaluate project by project. There are many examples of this, but another challenge we find, and this I think it's what we are looking into the future, is working with the soil from the ground where you go on site. It's something that it's feasible, and we demonstrated it in 2018, but it's challenging. It requires a ton of research, a ton of work. So I think the challenge there is, how can we make it repeatable? How can we make it scalable? How can we make people to repeat this kind of work and to have the knowledge? And I find really inspiring that a lot of people are getting interested in this. We are working with a lot of people all around the globe that are really passionate about this. So I have no doubt that in 5 years, there will be people somewhere in the world that will be able to reproduce this kind of projects. As I was saying, we work a lot with especially universities outside of here, because they have the knowledge and the means to make this kind of research, which is really a change of perspective in the construction materials. I also think that today some of the challenges, for example, the pumpability of the materials, the compatibility with the hardware will change. For example, in the end of last year, we patented a new system that we hope to have on the market soon, which is able to mix the material in a different way, and it's overcoming some of the issues that we had before for natural materials. So we also believe that in time, also the way the machines are built can improve and increase the range of material. I really like to think that this is going to be a rush, a competition between all the companies and manufacturers to make it more sustainable. And this, I think, it's the kind of competition we want to work in the market, because if everybody wants to make it more sustainable, I am really confident that everybody will make it more sustainable. And that's kind of what we're trying to do. And also with our mission, our product, we try to go there.
Absolutely. Thank you guys so much for that insight into the material side of 3D construction printing. Now, I want to ask, in our previous conversations, you've all mentioned something about deployment, and there's a lot of costs associated with that. And I understand all of you are taking, once again, a different approach to how do you mitigate, whether that be using a mobile printer or is it a different deployment. Can you tell us a little bit about it? And then we'll start with you this time.
With me?
Yes.
Oh, I didn't hear it. Yeah, so great question, because mobility and cost of deployment and operation of the machinery was one of the other fundamentals that we were taking very seriously before we start creating any machinery, the robots that we have today. So as you know, construction is all the time about logistics, and here in the United States, logistics are crazy expensive. So we were okay, the machine, the 3D printer, has to be very compact, very easy to operate, and it has to be very easy to deploy. And reasoning from that, we basically invented the type of machinery that we have today. And again, it's it's never existed before. It's really highly specialized equipment. And you can use just standard pickup truck and trailer, and both units, printer and mixer, they also mounted on the Caterpillar tracks. So they're basically like a little tanks, and one person can operate it. So in comparison, for example, if you talk about a gantry printers, gantry printers are massive. You need to assemble, disassemble them all the time. And think about this like IKEA. You can assemble a chair one time, but if you're going to assemble and disassemble it many times, it's not going to survive for a while, right? So it's too much operations and costs to deal with the larger machinery. And in the construction, you need to keep up with the very tight schedule and workflow. Otherwise, you're going to lose money. So yeah, that was the fundamental before we started creating the technology we have today. And we're really proud of it. So just one person can operate it. And less than 30 minutes is actually to set up the machinery and even move it to the next position. Because as you may know, because the mobility of and compact dimensions of our machinery, we can 3D print any sizes, so like any square footage. We can 3D print 1,000 square feet house or 100,000 square feet house. There is no difference for us, and we don't create extra costs for that. Only whatever you need to do is just take the joystick and move the printer to the next position, synchronize it, like attach it to the previous points. And we do have the video that it really it took 25 minutes, but it could have taken less if Trevor would prepare the G code correctly. But but practical it's like a maximum of 30 minutes. So yeah, mobility, it also comes down to the unit economics. So yeah, mobility and everything about that. It's like how you can reduce the costs, operation and deployment, and then also relocation to the next construction site. That's we believe that's the key, and this is something that we all the time put it forward before we start creating anything.
Hi, and that's amazing. So, Giulio, we saw in the very beginning that you guys have the biggest printer out of all three of our panelists here. So, how do you deal with setting up and deployment?
Yeah, so I think I will begin with a funny story. In 2015, the WASP was like a 3-year-old company, and we, in the path of going to be a 3D printing construction company, we accidentally designed and built the largest 3D printer in the world by mistake. And this is because we just chosen the wrong, I would say the wrong kinematic. So we were really into delta printers, we still are. And so we said, let's make a huge delta system, right? And it happens to be that it was 12 meters tall, something huge. And it was actually printing something small. And this was very good for us because it brought us a lot of visibility in the end, but also because we started a very deep thinking about the importance of the kinematic, how to make this machine really effective. So in the following 3 years, we created the basis of what is now our Crane WASP. And the Crane WASP is very focused on the idea of the setup. So it's something that is made out of standard aluminum trusses. This is not only for being cost effective. We didn't want to reinvent the wheel. We wanted something good and effective to transport and to move. And it happens to be the same thing that you assemble for events. And then we have like a core of the machine that will be fixed to this frame. The frame is modular, so you can assemble a single module in around 2 to 3 hours in 3 people. Something also that we stressed out a lot is we didn't want additional equipment. We didn't want forklift, cranes, additional stuff that you have to bring on site, spend money and stuff, having gasoline and operators that will have to do it. So the machine can be assembled in 3 people without needing of additional equipment. And this is something we've been working on a lot. The way it works is once you have this module, you can print on a diameter of more than 8 meters, meaning that you can print, say, a small unit of 50 square meter. And then what happens is, being modular, imagine it like an hexagon, you can assemble multiple machines all together. So you create a mesh of this machine that can work together. Or you can take the same machine and move it. So you disassemble it, again, a couple hours, and you assemble it again for printing. So this is something that is also part of our idea of reaching remote areas in the world. Everything can be packed up easily into a 12-feet container. So as you are mostly from the US, I guess it's a 20-feet container where you can put it all, and we can bring it on site. And then with 3 people, we open it up. The system in the end is a polar system, so it will rotate. And that's the way we found to make it as efficient as possible so far. We are actually working also on new kinematics that will be a side of this system in the future for different application and situations. But so far, I would say we are very satisfied. We've been already working around the world with the system, transported, carried also in very extreme environments, for example, on the hills, and so far so good. I would say you don't need even to get there too close to the machine. You can transport it by hand. So I will say we are pretty satisfied with the result so far.
Yeah, before we go to Bruce, I want to follow up with that. Giulio, in our previous conversation that you mentioned a big part of why Crane WASP exists is to repopulate rural area, and that is something that really stood out to me. Can you tell us a little bit about that mission?
Yeah, this comes a bit from one of the one of our claims that we use is we want to develop space economy on Earth, right? So there is a lot of research for building in space. You know, we also have research for using regolith, printing on the moon, right? But in the end, if we look at the globe, there are so many areas in the world that are not used today by humans because they are a bit more extreme. So we want to develop the technologies for getting back there, make it livable, make it places where we can enjoy good life, and we think construction is a part of it. So we like the idea that our technology is also looking into this. We don't want to think about these ideal spaces. It's easy to be there. We want to make a technology that can reach up to these areas and repopulate. I mean, cities are the way we think about the human civilization right now, but the globe is so much more. So I think in the future, we really need to find ways to get closer again to rural areas and to invert this kind of dynamic. And still today, a lot of countries in development where there is housing crisis are exactly these kind of rural areas. So we want to get back there and take advantage of these beautiful spaces we have in our planet to address the problem of the population.
Yeah, and on the same line, Bruce, in our previous conversation, you mentioned about, your printer is built to be tough, it's self-reliant, and that really plays a huge part into your deployment and as well as your setups. Can you tell us a little bit about what advantages it brings or disadvantages it brings compared to traditional construction?
Sure. So, yeah, and maybe just to create a bit of a broader horizon here, we're focused and see 3D concrete printing as not just able to address the clear housing crisis, which is global, and I don't want to diminish the magnitude of that. I mean, it's enormous, and it's probably one of the most important things to concentrate on. But in addition to that, there are huge issues with aging infrastructure in the U.S. and globally, and there are all kinds of issues associated with non-residential construction that also need to be addressed. And then there are, in addition to the commercial components, there are civil and governmental requirements that include, for example, disaster recovery after a natural disaster, whether it's a hurricane or a flood or an earthquake, and then military issues and rebuilding in areas, unfortunately, that are war-torn all over the world. So our view was to develop a very robust expeditionary grade, military tough, mobile capability that's self-contained, that can really just about go anywhere and operate on any kind of terrain, not just a manicured slab, but one that can, with other capabilities, even go into a rough rural area where you may just have to print on what exists, and use local materials to achieve your objectives. So our approach is to create a self-contained mobile 3D concrete printer that actually is self-powered and has the generator capability on board, not just to move the machine around and operate the printer system, but is sized to also operate the ancillary equipment, the mixer, the pump, and other things, so that you really don't need any infrastructure at all. And if you combine that with our ultimate objective, which is to be able to go into an environment and source the material locally, and if you have to bring in material, say admix, to ultimately create the concrete mix to meet the performance requirements, minimize what you have to bring in so that you're not constrained by supply chains or anything else. This means that essentially you could go anywhere on the planet and solve problems without having to have a very organized, contained set of materials that you bring with you. And so our approach is not to be proprietary with our mix, but to be very clear in terms of what the capabilities of the 3D concrete printing system that we provide is, and just make sure that we work with our customers so that they stay within those performance requirements. Ultimately, by doing that, we think that over time, people will be able to optimize the use of this system, minimize their cost, and maximize the flexibility from a construction standpoint, whether it's residential construction or non-residential construction or infrastructure.
Awesome. Thank you so much. So before we go to the questions that came in from our audience, I have one last question for you. If you had to say in one sentence, how do you think 3D printer fits into the existing construction industry? And how do you see that change in 5 years? I know it's a lot to ask you to summarize all that in one sentence. But Anna, if you're ready, would you like to start us off?
Are you asking me?
Oh, give me one.
Oh,
sorry about that.
Who are you asking?
Yeah, so I was just saying before we go into the questions, we're gonna summarize how do you see the current 3D printers fits into the current construction industry, and how do you see that in the next 5 years? And just one of them, and then we'll go to all three of you. We'll start with Anna.
Okay, yeah. In one sentence, I would say that it's really about the efficiency of the robotic solution. And it's possible to integrate this technology into current construction, supply chain, and infrastructure. Is the question about the machinery, how available it is, how it's easy for other people to operate it, maintenance and support, and also materials. I would say just started right now, and in 5 years we're just gonna see like and ask questions: is this house 3D printed or not? So yeah, I'm not sure if it's one sentence, but hope it's I made the point.
Nice. And Julie, would you like to go next?
Yeah, so what I can say is that I can tell you what I believe and what I hope. So what I believe and I'm pretty sure of, as we are also 3D printing manufacturers for other technologies that probably are a bit more mature in a different stage, like filament, granule, or clay. I think it's going to be a bit the same. It's a technology. So I totally agree with Anna when she says that this will compenetrate and be complementary to existing traditional technologies. I don't think it's going to replace stuff. Just like every technology, it will have its pros and cons. Then what I see today in other printing application is, in some cases, in some application, it can be a revolution. Because maybe for some constraints around it, let's say it's an emergency, say it's maybe cost saving, maybe some materials, then maybe it could be a game changer. I believe that for some application, traditional construction will still win and will always win. I mean, there are some construction techniques that have thousands of years. So it's difficult also thinking of competing with this. So it will compenetrate. And I'm also really curious to see how this thing is going to shape up. And I think that everyone now, users, manufacturers, are a bit experimenting on this. It's like a global experimentation field where everybody is bringing on application failures, results, and it's amazing to see how fast this is happening. What I hope that this can really provide an answer to reducing the dramatic impact we are having on the planet, reducing not only materials, but also this can provide a good solution in terms of social impact. This is something also personal, but that as a company we motivates a lot of our work. So this is what I hope, and but I don't think it's more like a feeling.
Sure. And Bruce, would you like to wrap us up before we go to the audience questions?
Sure. I would say in a sentence that in the next 3 to 5 years, we have to take the complexities of this technology and make them reliable and dependable and simple enough for customers to use it as a productivity tool without constant hand-holding by the manufacturer. Essentially, we have to make it as solid a product as a Caterpillar.
Yeah, that's true.
We appreciate the call out to our capstone sponsor, so thank you for that.
Sure.
So yeah, there's been a lot of questions that come in from the audience. We encourage all of you to respond to them afterwards. We'll just pick out a couple of them. To start off with, we have I am so sorry. English is not my first language. I'm gonna skip on the name, but he wanted to know, what is the maintenance of the printer like? And you will feel free to take it.
I can take it. So about the maintenance, right? So we designed our system in the way that you would need to do the maintenance or like a constant replacement only of those parts that are in constant contact with the abrasive material like concrete. So we designed it as like a slots with the special rubber, and rubber is something that concrete can stick to, right? So the robots or like the machinery that we created, it's like how everyone could easily go and change the rubber slots. And make sure that all of the parts where all of the abrasive material constantly come in and damaging basically these parts, they can be easily replaced. So we have the 7 years lifespan for our robots because it's basically like a CNC machine, right? So it's like all of the parts that we have inside our robots is basically the same as from the CNC machinery. They also IP67 grade for all of the external parts. So it can actually like be left on the site, no problem at all. All of the sensitive parts like electrical enclosures and electrical parts and hardware, they're all covered with the same level of protection. But like right now, maintenance can be pretty, for our machinery, is very user friendly. And again, it was something that we also were thinking about like in the beginning. After our experience in Dubai, it was like, oh my God, so many stuff went wrong, but we still 3D printed the house. So, and then we used the traditional plastering machine, for example. And that was honestly for this particular application, that was nightmare. We needed to clean it like every 2 hours, every 3 hours. It took a lot of time. And somebody would needed to constantly sit in and, you know, watching the chamber to make sure that the concrete is still like mixing properly. So after that experience, we're like, no, if you want to scale this technology and make people happy to use this technology, we can't use this existing plastering machines. So this is how we designed a mixer and pump unit we call Gary. And Gary, it's really like everything is available, easily accessible if you need to change something. So I would say that it was one of our top priorities to make this, whenever we create the robots, how everyone could not just only operate it, but also do the maintenance. And also another step, we incorporate a lot of software and sensors and hardware, so we can actually remotely do the, you know, look at what happens, and a lot of troubleshooting can actually happen remotely.
Awesome. So unfortunately, that's all the time that we have for audience question, but please go ahead and respond to them in the Q&A and chat after we're done. So we're going to take just a couple of minutes break and give you a second to respond to all the questions, and we'll be right back with our next talk.